Welcome, boys. During these classes, so we'll go through some of the numericals of the topics which we have already covered during different classes. So we will go for some numerical problems to understand some of the applications of these topics in our daily life, as well as if anyone asks you to solve some types of the problems. So here are some of the techniques through which we will solve the turning effect of the forces problems. So before we go to the turning effect of the forces, there are along with these, there are some other problems which are for the vectors as well. So here, this is from the same chapter, and mostly these chapters are common. Find the resultant of the following forces if you are given a force along x-axis, that is 10 Newton, and along y-axis, second one is about 6 Newton, and 4 Newton along negative x-axis. So here it is. If you are asked to find the resultant of the force, this is the formula to calculate the resultant of the force. Basically, here it is when you are calculating fx square plus fy square half, because when you draw x, y, and x-axis in between the two, there is another. This is the basically force, and you are asked to calculate the resultant of this force. So this is the vector, and if you draw a perpendicular on x-axis, you see this one is horizontal component, this one is vertical component, this one is fy, and this one is fx. And if you are asked to calculate the resultant, then how will you calculate resultant of the force? This is the formula. Both horizontal and vertical components are given, and you are asked that this one is 4 Newton along x-axis, and this one is a 6 Newton along y-axis. So 4 Newton along negative z-axis. So it means that you have to calculate the total force along x-axis, that is resultant force, that is 6 Newton. So you are asked to calculate the resultant, and formula to calculate resultant is fx square plus fy square, and this F force is equal to this one. So if you put the values, that is 8.5 Newton, and if you are asked to find out the direction, then here is the formula to find out the direction. Means you are supposed to calculate the angle in which direction this force is acting. So you will calculate the angle, that is Fy divided by Fx. So this one is Fx. So that is, if you put the values, that is Fy is 6 and Fx is 6. You put the values and you will be getting value of the angle of the direction is, it is exactly between x and y axis, and the angle is 45 degree. So if you look at the next one, find the perpendicular component of a force of 50 Newton making an angle of 30 degree with x-axis. So component of the force of 50 Newton, it means if you look at, here is the figure, and if you see how much angle it is making along, it is 330 degree along x-axis. And if you draw perpendicular from this point, this component is fx component, this component is fy component, and here has fy component and fx component. Fy component is already here done. Fx is equal to f cos theta. Force is 50 Newton here, and you are asked to calculate the component of this force, that is 50 Newton force. So along x-axis and along y-axis. So this is the angle, that is how much force is acting along x-axis, that is 50 Newton, and how much at what the angle it is acting, 30 degree along x-axis. You will use cos theta to calculate horizontal component, and this will be your horizontal component of the force. Similarly, you are given Fy, and you are supposed to calculate a vertical component. Again, the force is 50 Newton, and the angle which is making along the vertical, that is 30 degree. So you will put the values of these two and you will be getting Fy. Basically, you have already learned to resolve force into its horizontal and vertical component. To calculate horizontal component, this is the formula, F cos theta. And to calculate vertical component, this is the formula to calculate vertical component. So only you will be given such and such Newton force is making an angle along horizontal. You will be asked to calculate the component of this force, that is 50 Newton, horizontal and vertical component. You will put the values in the formula. First you will calculate horizontal component, then you will calculate the vertical component, and then you will find out. So with this, you have learned how to, today, you have learned how to find out the resultant of this force which is making any angle along x axis. So you will find the resultant of force. If you are asked to calculate the direction of that force in any case, then this is the formula to calculate Fy divided by axis. Fx, you will be given Fy component, you will be given Fx x component of the force, then you will be able to calculate the angle tangent inverse, that is the value given, the ratio between the two, and you will be able to calculate. So then the next one, we have calculated the turning effect of the force chapter. That is, if you are given some force and magnitude of that force, you are asked to calculate horizontal and vertical component, then it will be more easier for you to calculate. So if you look at the third one, this is again find the magnitude and direction of the force. Two questions: magnitude and direction of the force. If its x component is 12 Newton, means Fx is 12 Newton, and y component is 5 Newton. Here it is. So how will you calculate? You are calculate angle. Directions mean you are asked to calculate angle, and then you will calculate the magnitude. So first you calculate magnitude by taking the following the same formula, Fx square plus Fy square. You will put the values of horizontal and vertical component. Then you will be able to calculate the component of the force, resultant force. Then this is the formula to calculate the direction of the force. So with this, today's class we end up here. I hope you people have understood to calculate the magnitude of the force and direction of the force as well. Thank you very much for your patience.